At Dynamic Alpha Automotive Technology, we are excited to introduce the revolutionary Dynamic Flow Engine, a state-of-the-art four-stroke engine that stands out with its unique and innovative features. This engine showcases an advanced valve configuration highlighted by two exclusive technologies, the variable displacement feature and an infinitely variable internal EGR system. The infinitely variable internal EGR system allows the dynamic flow engine to dynamically adjust its emission controls in response to varying road and load conditions, delivering emission performance that surpasses current systems. Meanwhile, the variable displacement feature ensures that the engine consistently operates at optimal thermal efficiency, whether navigating city streets or cruising on the highway. This innovation enables future vehicles to benefit from larger, more robust engines running at lower RPMs without sacrificing fuel efficiency or performance. As a result, high-performance vehicles equipped with the dynamic flow engine can achieve fuel economy on par with that of economical sedans. Inefficiencies in conventional four-stroke and two-stroke engines. Traditional four-stroke and two-stroke gasoline engines experience significant inefficiencies when operating under partial load, leading to substantial fuel waste. While four-stroke gasoline engines can reach about 40% thermal efficiency in ideal laboratory conditions, their actual efficiency in real-world scenarios typically falls to around 25%. Diesel engines, though generally more efficient than gasoline engines due to their ability to run on lean mixtures, face the disadvantage of higher nitrogen oxide emissions. Conventional engines often produce more power than needed during partial load conditions, causing the excess energy to be dissipated as heat and expelled through the exhaust. Dynamic flow engines' approach to partial load inefficiency. The dynamic flow engine addresses partial load inefficiencies through its innovative, infinitely variable exhaust gas recirculation and variable displacement features. These technologies leverage a unique valve configuration to repurpose hot exhaust gases for both emission control and as a filler to displace intake air, thereby enhancing overall efficiency. While both features are based on similar principles, they differ in their fuel injection strategies. The infinitely variable exhaust gas recirculation system uses a static fueling approach, while the variable displacement feature employs a dynamic strategy. The variable displacement feature provides substantial benefits by controlling nitrogen oxide emissions, reducing hydrocarbons, and lowering fuel consumption and carbon dioxide emissions. Meanwhile, the infinitely variable exhaust gas recirculation system focuses primarily on managing nitrogen oxide and hydrocarbon emissions. The strength of the variable displacement feature lies in the engine's precise control of the infinitely variable exhaust gas recirculation system. By carefully adjusting the timing of the upper exhaust valve, the engine can accurately regulate the intake oxygen levels, effectively simulating a smaller engine size during partial loads without altering the compression ratio. This precise control allows the engine to optimize fuel injection strategies across varying load conditions, significantly reducing both fuel consumption and emissions. The variable displacement feature dynamically adjusts the engine's power output to match changing load demands, all without requiring physical modifications to the crankshaft or piston connecting rod mechanism. As a four-stroke engine, the dynamic flow engine follows the standard cycle order: intake, compression, expansion, and exhaust. Each cycle begins with the intake stroke and ends with the exhaust stroke. During continuous operation, the exhaust stroke of one cycle is closely followed by the intake stroke of the next. At Dynamic Alpha Automotive Technology, we recognize that this proximity between the exhaust and intake strokes in a four-stroke engine could be leveraged to create the infinitely variable exhaust gas recirculation and variable displacement features. In the dynamic flow engine, the timing of the upper exhaust valve is crucial for controlling exhaust gas recirculation. By advancing the upper exhaust valve timing, the engine increases the volume of exhaust gases recirculated. Neutral timing results in no recirculation. This internal exhaust gas recirculation occurs at the cylinder level, eliminating the uneven distribution of exhaust gases that can affect charge air in multi-cylinder engines. Unlike traditional exhaust gas recirculation technologies, whether external or internal, The dynamic flow engine has the unique ability to vary the recirculation ratio on demand, thanks to its valve cam timing mechanism. To achieve variable displacement, the engine first adjusts the recirculation ratio by setting the upper exhaust cam timing. Once this ratio is established, the engine recirculates a volume of exhaust gases corresponding to the set ratio, displacing an equivalent amount of atmospheric intake air oxygen with these gases. Fuel is then injected to combust with the modified intake air oxygen volume. The dynamic flow engine can incrementally control the displacement between 0% and 100% in 5% increments, allowing for precise and adaptable performance. Dynamic flow's methodology for infinitely variable exhaust gas recirculation and variable displacement. The variable displacement method in the dynamic flow engine begins with the advancing of the upper exhaust valve timing during the expansion stroke. By advancing this timing, the upper exhaust valve closes early during the exhaust stroke, trapping exhaust gases in the upper non-combustion chamber. As the intake stroke of the next cycle follows the exhaust stroke, the stored exhaust gases in the upper chamber are allowed to flow into the combustion chamber before the intake air. During the compression and combustion strokes, these exhaust gases displace a portion of the intake air in the combustion chamber. The ratio of exhaust gases to intake air can be precisely controlled through the variable valve timing mechanism. More aggressive advancement of the upper exhaust valve results in a higher volume of exhaust gases relative to the intake air, while less aggressive advancement leads to a smaller ratio. The fuel injection is dynamically adjusted in sync with the upper exhaust valve timing. With more aggressive advanced timing, less fuel is required, while less advanced timing calls for more fuel. This synchronization ensures that the air-fuel mixture remains optimal, even when the intake air volume is reduced. To achieve optimal performance, the dynamic flow engine continuously fine-tunes the fuel injection strategy in response to the varying air intake oxygen levels. This precise coordination enables the engine to maintain peak thermal efficiency across a wide range of load conditions and RPM levels. The transitions between full and partial displacement are smooth and instantaneous, occurring within milliseconds, ensuring that the engine's performance remains responsive and without sluggishness using this technique. The dynamic flow engine is designed to adapt seamlessly to various operating conditions, ensuring consistent peak performance regardless of the load. By utilizing an innovative, infinitely variable internal exhaust gas recirculation and fuel injection strategy, the engine achieves the advantages of variable displacement without the added complexity or potential reliability issues that come with physically altering key engine components like the crankshaft or piston connecting rod. In conventional four-stroke engines, early closing of the exhaust valve during the exhaust stroke is not feasible because it requires the valve to open earlier in the expansion stroke, which would interfere with the engine's normal operation. However, the dynamic flow engine's unique valve configuration allows the upper exhaust valve to open early in the expansion stroke without negatively impacting the stroke's performance. Unlike two-stroke engines, which lack distinct intake and exhaust strokes, the dynamic flow engine can effectively use this advanced internal exhaust gas recirculation technique. With its infinitely variable internal exhaust gas recirculation and variable displacement features, the dynamic flow engine offers superior emission control and fuel efficiency.